Okay, so I'm re-recording this lecture, so I'll actually go through this fairly quickly, just to make sure that everything winds up getting heard correctly. So here, we'll quickly distinguish fairness versus bias. We'll talk a little bit about the legal environment selection and then spend most of the time distinguishing between the different types of differences that occur, focusing mainly on mean difference, differential validity, and differential prediction or differential regression. I'll mention briefly differential item and test functioning, but that's not a really significant part of what you need to worry about knowing. The main thing here is to know that we do see differences in average scores between important groups on various kinds of selection tests. Just going to turn my camera off for a moment here. For example, we'd already talked about cognitive ability. So like North American whites typically have an IQ of about 100 in the traditional IQ standard. That's the average, and that's because that's how it's built. I mean, that is a baked in bias. Like the original tests here, that's how they were constructed, so that's just what you would expect. North American Asian populations score about a standard deviation higher, and African or North Americans of African descent score about a standard deviation lower. Now that's worth noting because especially on that end with the North American, Black North Americans, that's been closing. Like everybody, I mentioned briefly when we were talking about cognitive ability, the Flynn effect. Like people are getting quote unquote um, smarter over time. Like the average score is rising, but it's rising faster for North America, Black North Americans than for other populations. And partially this is a reflection of improving social conditions, increased access to educational and other resources, decreasing modest decreases in poverty, all of those sort of improved in nutrition, all of those sorts of things compared to when these records started being kept. This re-emphasizes some of the points that we were making previous time, that when we're talking about differences in measured quote unquote cognitive ability, intelligence, or IQ, that these are reflective of complex things. So you should never just be like, oh, um, people from one group are smarter than a different group or dumber than a different group or something along those lines. But regardless of whether or not these differences were show, which, as we'll talk about briefly, contributes to potentials for adverse impact, there could still be bias even in the absence of this. So we talk about fairness. Fairness is just the way we subjectively appraise whether or not something is just. So this is dependent on individual and social, and particularly social values. It's something that we just do, whereas bias is a technical concept, and it's matured over time. But it's really how are we going to assess whether or not the decisions we make with a given tool are fair, and particularly now it's really concerned with whether or not a particular predictor, so this could be a test, interview technique, anything we would use for selection or other personal decisions, whether it accurately or inaccurately represents a person's likelihood of future performance. So as you can see, like fairness, like our societal concepts of fairness are always going to have an influence on how we operationalize our assessments of bias, but they're not the same thing. Um, Again, just a reminder about the difference between adverse treatment and adverse impact. So for instance here, if we know that there will be a difference in selection rates between groups, and we intentionally choose a selection measure because it will discriminate against one group, that would be adverse treatment or disparate treatment. Whereas we could be using a perfectly valid, in the sense of predictively valid, selection measure, and it could result in differences in selection because groups have different means on it, so they score differently, and that could result in adverse impact whether we intended to discriminate or not. So I don't really want to worry too much about this. We've talked about these things, and that's more focused on the American except to mention the concept of the 4/5 rule again. And the basic idea here is that in general, if a lawsuit is being brought, like you've already seen this slide when we talked about it and people understood the 4/5 rule, I just want to talk about its usage here somewhat in the way litigation works. In this case, like when a candidate, say a candidate who wasn't selected, or even one who was, for various reasons, or anyone who's going to bring litigation against an employing organization. At first, it's become incumbent upon them typically to demonstrate that there has been adverse impact, and that will usually, this is where the 4/5 rule often shows up. In both American and Canadian cases, is to show that there is a more than 4/5 or greater than the 4/5 rule gap between the selection ratio for the majority group and whatever protected minority we're interested in here. And then once that happens, then the burden of proof will typically shift to the employing organization to demonstrate the bona fide occupational requirements, validity, and those sorts of things. So in general, we have three issues when we're assessing bias, which are what are we measuring, and does the predictor make unbiased predictions about future performance? I'm going to say three issues, but it looks like two. But the issue is that with that unbiased predictions, there are two components, which in more technical jargon will be, is there construct validity for the predictor, right? And in this case, really what we're trying to say is it actually job relevant? And so have we identified a dimension of human skills, abilities, or other characteristics that or knowledge that is relevant to the job, and does the test actually measure that? It's not really what we're concerned with here. That's more the kinds of validation stuff that we've talked about before, and particularly job and like that. If you're using a predictor because that it is based on a solid job analysis, you're probably okay there. Here, the interrelated issues are: does the test demonstrate an intercept or slope difference between the two groups, right? And so this is the fact that what we're going to be looking at is it equally valid for both groups, and are the groups like indistinguishable from one another in terms of performance. So in terms of assessing bias, what we're going to be concerned with is the mean difference. And when we're talking about mean difference, we're talking about mean difference on the predictor, right? So like if what we want to see here is that, this is the majority group, this is the minority group, that they have the same average, but if they pull apart like this, if the minority group or the protected group has a lower average score on the selection measure, they're going to be selected at a lower rate. And so that could cause problems with adverse impact. Then we got differential validity, which is just literally is the slope. The correlation, the validity coefficient is the same for both groups, or are they different, right? Is it more valid for one group in particular? If it's more valid for the majority group, well then the decisions that we're making for them are probably sound, whereas the decisions we're making for the protected group, the minority group, are probably not sound, or at least they're certainly not equally sound as they are for the majority group. And then with differential prediction or regression, is the same score of the predictor associated with the same performance for members of both groups? And that can be due to two reasons. Like the slope can be different, just as we talked about with differential validity, or the intercept can be different. So we could have the same slope, but different intercepts. And that would mean that the groups have different average performances, essentially, or different distributions of performance. So, and that leads to the possibility of over versus under prediction. So over prediction occurs when the regression implies that there's going to be a higher level of job performance than really happens. And under prediction is just the opposite. It's when the regression says that a person is going to do worse than they would otherwise. And for a variety of reasons, just generally the sample size is relatively small. Like in any particular setting, we rarely find empirical examples of differential regression. So there's neither over nor under prediction. And this research was old at this point. So it's from the 1980s. So, it's almost as old as I am. When we find it, we usually find over prediction. And by that, we mean over prediction for the minority group. That's what this typically matters, which means that the regression system actually says that they're going to be doing better than they really are. And that's something to be somewhat concerned about for reasons that I would hope are fairly obvious. So here is, well, it's got my squiggles on it. We've just got the situation here where we have everything is identical here. I'm just gonna try. Oh, no, I can't. So I'm just gonna try coloring things in. We've got one regression line here, and we've got one validity circle here. So it doesn't matter whether you're scoring down here. It doesn't matter whether you're from the minority or majority group, you have the same predicted score. Or if you score up here, it doesn't matter if you're from the minority or majority group, you score up here, right? So there's no group difference, there's no differential validity, right? The validity coefficient is the same, and there's no differential prediction because there's no differences in intercept between the groups. And again, just a reminder, if there is differential validity, there will be differential prediction, but but even when there's no differential validity, there can also be differential prediction because of difference in intercept. So again, we could have the situation where there are parallel regression lines, but that would lead to someone in this group has a lower predicted score than someone in this group, even though the validity is the same because the slopes, the regression lines are the same. So here we go. In this case, we have there is no group difference, right? And again, remember, group difference is about the predictor. So these have the same, to the limit of my drawing ability on here, the two groups have the same distribution on the predictor, so there's no mean difference, but there is differential validity, right? So for this unshaded group, there is no predictive validity. There's a 0, whereas for the shaded group, there's a substantial predicted validity. So the basic idea is, like, if I'm in the unshaded group, I'm just going to change my color here. It doesn't matter where I score. I should have the same predicted validity because this is not, or the same predicted performance because it's not a valid test for me. Whereas if I'm in the shaded group, if I score here, I have this predicted validity. If I score, or predicted performance, if I score here, I have this predicted performance, right? Here we have a situation where we have a group difference, but no bias, right? So this is that there is a common regression line. So the validity is the same, the intercept's the same, there's no difference between it. So regardless of which group I'm in, if I score here, I have this predicted performance. If I score here, I have this predicted performance, and it doesn't matter what group I'm in, I have the same predictions, but there are differences in predictor score. This is what is sometimes in the business called impact, right? So impact is a real difference. Like people in the brown group or the gray group have an average that's, well, actually, let's try it a little bit better. So something like this, whereas in the light green group, their mean would look something like this. So the light green group has a higher average score on the selection test than the shaded group, which is down here. So again, there would be adverse impact here, right? People coming from the gray group would be selected less. Well, I shouldn't say there would be adverse impact, but there would be differential selection ratios. People in the gray group would be selected less often because they, on average, score more poorly. And if they got selected, if there was a big enough mean, if the mean difference was big enough between these two groups such that the selection ratios were substantially different enough to lead to a violation of the 4/5 rule, then there would be strong evidence of adverse impact. Right? Now, as long as this was based on a good job analysis, because there's no differential prediction and no differential validity, the organization using the employing organization using the selection system would probably be legally fine, but they would have to get to that point. And this is just illustrating that again. Again, sorry, like this is just, I was trying to re-record over what was there, so I've still got my my old drawings in here, unfortunately. So here we wind up with this situation. So we have a group difference with bias and differential validity, right? So because there is differential validity, there will be prediction bias, right? Because there's a different slope for the light green group. So and again, here the light green group here has this kind of a performance distribution, whereas the gray group has this kind of a performance distribution. So the gray group's mean is up here, the green group's mean is down here, and so they have, and the green group is also invalid, like in this example, it's invalid, like it has essentially a zero correlation with predicted performance, whereas the gray group has a substantial relationship with predicted performance. So again, wherever I would score in the green, if I was from the green group, even if I had a high score, it wouldn't be up here. It would be, my predicted performance should be down here. Because this test is just not valid for me. Whereas if I'm in the gray group, if I score up here, it predicts my performance down here. If I score down here, it predicts my performance over here. So, they know this is messed, but the basic idea is if it's differentially valid, there will be different predictions, and therefore the test is going to make flawed predictions. So here, if, in particular, if the green group is protected, like if they have protected status under, say, the human resource, or, the Human Rights Charter, then, they have a lower mean. So again, just like I talked about last time, since there is a mean difference, we will see differences in selection, and therefore if the differences in selection ratio become large enough, there would be adverse impact here. But the employing organization would not be protected in this situation because the test is invalid for members of the green group, right? So they would not be able to demonstrate that it makes equivalently accurate predictions for the gray group versus the green group, and therefore the employing organization using the selection system would probably be held liable under most circumstances, unless they had some other bona fide occupational requirement argument to fall back on. So again, just to show these predictions again. So here with the green group, we would have, if we were properly using this, that we would have the same predicted performance for people no matter where they scored if they were in the green group. Whereas in the gray group, you have a very accurate and highly valid predictor. Up here, this is an example where I've just used something where, so for let's give something like a university entrance exam, like used in the United States, so something like the SAT, right? Here we have a situation where, at least traditionally, this is actually not so much the case anymore, but where men and women don't really have any major differences on the predictor. Like basically, it doesn't matter which group you're from, you score pretty much the same. Like on certain subtests, there are really, really minor differences between men and women, but they're nothing important to speak of. And the test is pretty much equally valid for men versus women. Like whatever you score, there's predicted university performance, like predicted first year GPA associated with it. No real differences, except for the fact that, or at least equally valid, like it in terms of correlations predicts equally well. But historically, women did better than men in university, partially because they tended to quote unquote behave themselves better. Like men, like they'd go to university and they'd party and get drunk and wouldn't study and did worse on average. Women have actually caught up in this setting. Like they y'all behave almost as badly as we do, or something along those lines. But anyways, like this gap has closed. So the idea here is this is equally valid in the sense that the correlation between scores and outcomes are the same. So the slope of this regression line is the same for men versus women, but again, historically, women performed better than men. So if we were going to use, I'm going to use red again here, if we were going to use this sort of common regression line for both groups, women would be underpredicted because if they scored here, let's say we're talking about this score, if they scored here, women would be predicted as having this score, but they should be predicted as having this performance. Whereas men are going to be over-predicted because if we're using the common regression line, well, they'd have the same predicted score here, but they should be predicted as having a score around here. Right? So that's what it's looking at. So, and again, just to reiterate, if there is under or over prediction for one group, there's the reverse for the other group, because essentially what's happening is we're going to be using the common regression line for the two groups, and if one of them is under predicted, then therefore the other one has to be over predicted. So in this case, women are being under, their performance in university is being under predicted, right? The model says that they're going to do worse than they really are, and men are being over predicted. The model is saying they're going to do better than they are, and that's just the way it falls. If you have a common regression line between the two, they're going to end the same validity. The regression line is going to fall in between the two groups, and therefore, if one group's being overpredicted, the other group's being underpredicted. Just to illustrate again with those slides. Here we have no group difference with bias but no differential validity. The same basic idea happens here, except we've just flipped the groups. So everything else is the same. It's just in this case the green group will be over predicted, and the gray group will be under predicted. Just to show that it doesn't really matter which group is which, like the technical phenomenon is happening. The only thing that what really matters is if the group that's being underpredicted is protected under something like like various civil rights laws in the United States or the Human Rights Charter in Canada. If they're protected and they're being underpredicted, well then they're going to be selected at a lower rate than they should be because their predicted performance is not as high as it should be. And so we're going to make mistakes that favor the majority group unfairly. So just a quick statement about differential item functioning and differential test functioning. This is a complicated thing that can only be assessed with a very sophisticated model called item response theory, which I may have briefly mentioned. We talked about psychological measurement at the beginning of class. The basic idea here is just if a person from the minority group has a lower chance of getting the item right than a majority person of the same ability level, then the item displays differential item functioning. And if you have a bunch of biased items, especially if they're all biased in the same direction, the test displays differential test functioning, which is basically just a way of saying that it's biased against the minority group or the protected group. And this is just a way to show it here. So in this case, like men have a lower percentage probability of answering the item correctly everywhere. So than women do. And it's also true here, except here the lines are totally parallel throughout their range. Here, it's also less discriminating for men, for what it's worth. The other thing about this is just when items display differential item functioning, sometimes it's obvious. So like an example I like to go to is once upon a time, the SAT included a question that was just a basic math question. It required no special knowledge about content, but it was couched like it was a word problem that was couched inside a question about baseball. And again, it was just using basic probability, like that's all it was, but the context was all about math, it was all about baseball. And therefore, like you didn't need to know anything about baseball in order to answer the question, which would be completely biased. But people who didn't know about baseball had a harder time putting the numbers together in the correct way. So it was generally biased towards people from, well, countries that play baseball. So, I mean, the United States, Japan, Cuba, really, like, I guess Canada too. Um, but in general, like, I mean, countries that do not have relatively strong baseball traditions, generally students coming from those backgrounds had trouble answering that question. It's not necessarily unfair because the question didn't actually assume baseball knowledge. Like, you didn't have to know anything about the rules of baseball in order to answer the question, just the context made it difficult. Whereas on the other hand, a pretty classical example is a question like one of the standard analogy questions, like or this is to this as blank is to something else. One of them was involved the word regatta as the point, and people just don't know that word. I happen to know it because I was a Boy Scout and we had an event called a rain gutter regatta. A regatta is a kind of sailing race, and we made model boats and you like blew on them and tried to race them. So I was kind of familiar with it, but in general, like this was heavily biased towards at least upper middle class, if not upper class individuals, particularly from sailing regions. So like the northeastern United States. So they had like, people from that background had very little difficulty answering the question, whereas other people just were like completely flabbergasted by it. So those are examples of where different like the differential item functioning can come from. But sometimes we identify items that have differential item functioning and it's just totally unclear why. There's no obvious reason. So in general, like large testing programs like the SAT or sometimes like things like nursing licensing tests and those sorts of things. Um, they'll just test items to see if they display diff and just get rid of them if they show it, even if they can't figure out why. If you can figure out why, sometimes you can rewrite questions so that you can save the content, but a lot of times they just get rid of them. Anyways, that's about all there is. Cheers.